that your end result is this. So as a normal exponent, the answer is rather clear. It's just 4 times 4 times 4. But as a negative exponent, the result is this, which happens to be the reciprocal of that. Kind of interesting, huh? This is literally 64 over 1. This is its reciprocal. Let's do another one. Let's do 5 to the negative 2. What am I going to do with it? I'm going to place it in the denominator of a fraction. And notice I stopped, I wrote it from here to here. I removed that negative symbol. By moving it from here to here, I have started to simplify it. Looks like it's 1 over 25. And 5 squared is 25, right? Reciprocal? It gets a little bit trickier, but not by much. Before I show you any more on negative exponents, I want to show you zero exponents. The definition of a zero exponent. Anything to the 0 power you'd think means it's a 0, but it's not. It's 1. Anything to the 0 power is 1. 12 to the 0 is 1. 1,562 to the 0 power is 1. Kind of getting the trend here. Memorize this, guys. Anything to the 0 power becomes a 1. Some of you might ask them, what's the point of that? I can illustrate that in your future, not right now. Just know, anything to the 0 is 1. By the way, this has all been part of example 1, but I wanted to introduce what you do if you see a negative exponent and how you answer it. So if I say to you, write this expression using only positive exponents, then you could simply answer it this way. You could go to that point. You don't actually have to go all the way to here. You can, but you don't have to. Okay? I would prefer it if it says only use positive exponents, just go this far, because that's going to be the book answers for you to help you out. Okay? This is how far they're going to ask you to go. Rewrite this using only positive exponents. There's your answer. Okay, so what do negative exponents look like? What does a 0 exponent look like? Now, what if I added a little more detail to this? What if I said to you, all right, let's take it a step further. Let's mix it up a little bit. We're still in example 1, I'm sorry to say. A to the negative 5th, B to the 0. Remember that anything to the 0 power becomes a 1. That means this no longer says a to the negative 5th times b to the 0. It now says a to the negative 5th multiplied by 1. Which, if you want to take your time on it, looks like that. But write this using only positive exponents. Rewrite this in the denominator of a fraction below a 1. And you have your answer. Okay? That's how something like that would be solved. Or how about this? W to the 0, x to the negative 2. What happens to the W to the 0? What does it become, class? A 1. Which, breaking it down, means it's now 1 times x to the negative second, which becomes 1 over x squared. Taking your negative exponent, rewriting it as the denominator of a 1 with a positive exponent. 1 over x squared. The last part, and yes, we're still in example 1, is when it gets even trickier. 4 multiplied by m to the negative 4th times n to the 3rd. You need to look at each of these components separately. 4 times m to the negative 4th times n to the negative 3rd. I'm going to rewrite the 4 because there's really nothing weird about the 4. 4 times m to the negative 4th. What do I do with m to the negative 4th? Eli, what do I do with m to the negative 4th? Put a 1 over it, and instead of being m to the negative 4th, it is now m to the what? Good. Okay, and n cubed. Is there anything weird about n cubed? Nope. So now what I'm left with is 4 times 1 over m to the 4th times n cubed. Multiplying fractions with whole items is easiest accomplished by putting a 1 underneath. So I threw 1 under 2 of those things. Your result should be in the numerator position 4n cubed. Your result in the denominator position is m to the 4th. We're going to practice a few of those shortly. That's example 1. I know it's a lot. Here comes example 2. What if I give it to you, oh, I almost wrote it as an exponent. What if I write it for you in this form and say, rewrite it without using the fraction bar? In other words, convert this back to that. So far you've learned how to take negative exponents and write them this way. Now you're going to learn how to take these items and write them that way. It's not as tricky as it may seem. Right now I'm going to start with 1 over 25. And I'm going to kind of go backwards the same way I did here. It's not by accident that it's the same one. So if I say this, let's convert it to an exponent. 25 as an exponent is what? Any ideas? I know Sarah knows. Who else knows? What can I write this as using an exponent? Emma? 5 squared. Super. But they want me to write this without using a fraction bar. So how can I indicate 1 over 5 squared without using a fraction bar? Stu, go.
Would be 5 negative, would you call it negative second?
Yeah. 5 to the negative second. I wouldn't do 5 negative squared. I just never heard it that way. So yeah, you can say it that way. 5 to the negative second, 5 to the negative third, 5 to the negative whatever. So we went from here to here. And this is example 2, taking a fraction bar and rewriting it as a negative exponent. How about x over 36? X over 36. Can we rewrite this? We sure can. X over, what is it, 6 squared? And let's maneuver this the same way we did. And look, at the 1 didn't disappear. It's 1 times 5 to the negative second, but you don't write that, do you? You never would. But here we still have something in the numerator position that we have to keep track of. So it becomes x times 6 to the negative second, which normally you would write it 6 to the negative second times x. In any case, we took this and moved it up, and now we no longer have a fraction bar doing what they asked us to do. And here's the last one in this bunch. Letters only. No, wait a minute. That's not right. X 6 y cubed. They want me to rewrite this without the fraction bar. Obviously, there's no like easy root thing like this. It's not like we're taking the square root like we did here or here. But we are going to move this up and make it x6 times y to the what kind of third? Negative third. Yep. And there's several more examples just like it in example 2 on your page 200 in your book. Okay? Those are all in there for you to try out. Okay. It's going to take a lot of practice, my friends. Here's example 3. Example 3. And in your book it says using powers properties with negative exponents. How do I deal with multiplication and division when you have negative exponents? Well, remember, when you are multiplying with the same base, what was the rule? What do? We add the what? Anybody remember what we add? Go ahead. And keep the base. The rule for division was division with the same base. You subtract the exponents. Right? Well, let's take, for example, this first one. 3 to the 8th multiplied by 3 to the negative 10th. Before you even start doing any of the moving around, let's add our exponents together. What's the result of 8 combined with a negative 10? Ryan, 8 combined with a negative 10 is what? A positive 8 and a negative 10. Negative 2. It's a negative 2. And we're not going to leave this like this. It becomes 1 over 3 squared, which is 1/9. So if it says to you, write your answer using only positive exponents, first you're going to add together your exponents. Then you're going to maneuver so that you have a positive exponent. And this is the answer you'll see in the back of the book. But I wanted you to see in the real world what that number looks like. 1/9. So same base. It doesn't become 9. It stays the same base. This was an example of multiplication. This is the first example in example 3. Letter B is division. And you have a book example, but mine looks like this. 10a to the 4th divided by a to the negative 4th. Now there's no coefficient, so it's 10 divided by 1, right? If we perform the 10 divided by 1 portion, it's 10. Now we have to deal with the bases and their exponents. Is a the same as a? Then what do we do with the exponents? Subtract them. What is 4 minus negative 4? And it's not 0. 4 minus negative 4. I know a couple of you know. What about the rest of you that want to participate? Rachel, go ahead. Yep. And you end up with that. Your new answer written using only positive exponents looks just like that. Okay? I'm going to go ahead and click this out